Okay, so previously, in the previous session, we looked at Newton's Raphson method to solve this problem here. Okay, in this video, we're going to look at the second method, which is a modified Newton's Raphson method. So every time we hear a second method, just know that we're dealing with a modified Newton's Raphson method. Okay, so just like I mentioned in the previous session that we had, I said that, the only condition that we have for Newton's Raphson method is when the derivative, okay, we have a problem. What if the derivative is equal to 0? That's the only problem that we have, okay? So f prime, okay, of f prime at xn minus 1 should never be equal to 0 as a condition. And of course, sometimes you find that you have a function which is very much complicated, okay, which is a complex function, and as a result, you find it challenging to find the derivative of that function. Okay, so you find it challenging to find the derivative of that function, and because of that, second method becomes more useful as compared to the Newton's Raphson method in problems like the derivatives are very complicated. For instance, if you look at question number 2, okay, for you to get the derivative of the question number 2, you have to use product rule. Okay, you see, you have 4 e to the power negative x, e to the power negative x, sine x, whatever. For you to differentiate this one, of course, you need to apply product rule. Okay, and that is another work to do. So to avoid that, we introduce the second method. Okay. So second method doesn't require you to find the derivative of a function. Okay. So how is this second method? Okay, so it's a modified Newton's Raphson method. So I'll share this PDF in case someone needs it, right? Okay. For those who are not writing, but I'm not encouraging you to stop writing.
We are writing. It's only that today you're very fast.
Today I'm very fast.
Yes. So
Okay.
when we are doing some calculations, you already have the answer.
Okay, I'll slow down provided you help me give me those answers.
Okay.
Okay, I don't want a situation whereby I ask people are just quiet. I want this class to be active. People should be involved, okay? All right, so this is a modified Newton's Raphson method. Okay, let me not add the modified part for now. I think there's also another part that we need to look at the modified modification. I may just end up mixing this. So Newton's second method, you just have to do a bit of modification to what? Newton's Raphson method. So how is that modification done? Okay, so let's see. Let's find out. So just like I said from Newton's Raphson method, I said that xn is simply equal to what? Xn minus 1 minus f of xn minus 1 over f prime of xn minus 1. So this one is what? Newton's Raphson method. We looked at this, okay? So this is Newton's Raphson method. However, there is a problem. So, okay, we want to avoid the situation where the derivative of the function is complex. Okay, the function itself is complex and find its derivative is quite difficult, right? Okay, so how are we going to handle that problem? How are we going to handle that problem? Okay, now, just a minute. Okay, just a minute, just a minute. Okay, let's proceed. Sorry for that. Okay. So someone said there is no power. Okay, sorry. Yeah, Wazesco wamuvutani. Wazesco. Okay, so let's continue. Now I said, oh, there are situations where the derivative of the function might be very difficult to find, isn't it? So how are you going to handle that situation? So we have to redefine what the derivative is. So remember that if you say, oh, from actually, is it secondary or high school? I call it like that. Okay. From that, we know that, oh, well, the derivative is actually the slope with the line at a point, isn't it? Okay. It's the slope of the line. That's a derivative. That's a dimension of derivative. And we know that the slope of the line, okay, the slope of the line, slope, which is, we know this one, we used to denote it by m, right? Isn't it? This is the gradient, right? It's simply going to change in y divided by change in x, isn't it? Okay, we used to say this, right? And we even had to say, oh, this is y2 minus y1 divided by x2 minus x1. We used to say this, isn't it? So that is a slope. So this is it, the y prime. So that's a derivative, okay? This change in y over change in x is simply y prime, or the derivative. So we can also say the same thing here, okay? We can say, okay, this f prime at that point, okay, can be defined. So for us to find the slope, remember that always we need to have 2 points, isn't it? So it means that we need to have 2 values of y and as well as 2 values of x. So this is the reason why second method, for you to use second method, you need to have 2 initial values. Okay, so second method, the one part, the one job we need to, or maybe the one difference is that you don't have to use a derivative. Also, you need to have 2 values as initial values for you to use it, required for you to use second method. Now, let us substitute here. So instead of saying, oh, y prime, I'm going to name this what? Okay, f prime at that value, xn minus 1. So instead of saying y prime, I'm going to name it what? F prime at xn minus 1. And then instead of this saying y2, right? Okay, instead of this me saying y2 this, I'll name this as what? Y of n minus 1. And then this is y1, it will be called what? It will be called what? Y of n minus 2. Okay, so let's define this. So f prime, okay, so f prime at xn minus 1, this now can be written as, okay, change in y, so this will be yn minus 1 minus y2 minus, or yn minus 2, sorry. This is yn minus 2 divided by xn minus 1 minus xn minus 2. Okay, so it's more like y2 minus y1 over x2 minus x1. For example, if you say okay, let me find the slope. Let me say for n equal to 1, n equal to 2, right? N equal to 2, you're going to see that this will be y1, okay, because n equal to 2 minus y0, right? Divided by x1 minus x0. Or n equal to 3, this will be y2 minus y1 over x2 minus x0. So everything just the same, isn't it? Okay. Okay, now, if you, instead of writing yn minus something, okay, remember that y is actually the value of a function at a given point, isn't it? This is xn minus 1, xn minus 2. Remember that y value, okay, if you have a value of x at a point, to get the value of y at that point, it will be f of x, isn't it? That's the definition, right? So this f of x will be the value of y. So instead of me writing yn minus 1, I can write now this one as what? F of xn minus 1 minus f of xn minus 2. Divide by the value of x, which is xn minus 1 minus xn minus 2. So this is what we mean now. So in place of f prime of xn minus 1, I'm going to replace what? F of xn minus 1 minus f of xn minus 2 divided by xn minus 1 minus xn minus 2. So this is the replacement. So instead of me having the derivative of a function, I can instead use this, okay? Because having a derivative of a function, find that the function is to get its derivative is very much cumbersome. So this one will help us. So I'm going to substitute this in place of f prime of xn minus 1. I'm going to substitute this in the Newton's-Raphson method formula. Okay. So let's do the substitution. So therefore, Newton's-Raphson method formula becomes like this. It's not working. What's wrong with this? So Newton's-Raphson method formula now becomes xn is equal to xn minus 1 minus, okay, so this f of x of n minus 1 is still there, but what we are going to substitute now is a derivative, right? Okay, so we're going to divide this by what? We're divided by the derivative now. What is the derivative we've gotten? We've gotten this guy as a derivative, right? You see? F of xn minus 1 minus f of xn minus 2, okay, divided by over x of n minus 1 minus x of n minus 2, right? So now remember that the rules of the division, you can now swap those two, right? By using multiplication. So it means that this guy x of n minus 1, x of n minus 2 go on top, isn't it? So it means that we're going to end up having f of xn minus 1 times c. So I'm going to put these brackets. Okay, x of n minus 1 minus c, x of n minus 2 on top. And then down here, you're going to have f of xn minus 1 minus f of xn minus 2. Okay, so now this is now our second method. So this is the second method. This is one you use. Okay, is everything okay up this far?
Yes.
Okay, so now this is a second method. So you notice that when you use the second method, we don't need to have the derivative. So what are the requirements? So the requirements for this, the requirements are that, okay, let me start with a condition where this is not applicable, right? Let me start with writing a condition first, where it's not applicable, because every method has got its own limitation, right? Oh. What's wrong? Why is that not working? Anyway. Okay, so we need to make sure that f of x n minus 1 should be equal to f of xn minus 2. That's a condition, meaning this guy should not be equal to this guy. What happens if they are equal? There is 0 in the denominator, right? That's the only condition that we have. Okay, that's the only condition that we have. And also, two initial values. Initial values. That is what? X0 and X1 are required. Okay, so for you to use this method, you need to have two values. As you can see, of x of n minus 1 and also f of x n minus 2. So you need to have two values for you to use this method. You have to be provided with two values. If you're given one value, you can guess the other one, can just approximate, which is the other one should just be close to the given the one that you've been given as close as possible. Okay, should be as close as possible the one given to you. So you may be given one value, but you can just say, okay, let me just estimate the other one. Let me just start with any value which is close to the given value. Okay, so that is all about second method. Now let us see how we can apply this method, right? So we're still going to use the same. Yes, please.
Okay.
Yes, please.
I'm behind on the notations. Yeah, there.
Okay, so what's the problem?
Is it not supposed to be xn minus 2, then minus xn minus 1?
No, it won't matter, I think. There's no problem.
It's the same?
Yeah, it's the same thing.
All right, okay.
Yeah, there's no problem if you swap them, because if you have 2 points, the slope can also be found as what? Y2 minus y1 over x2 minus x1, or y1 minus y2 over x1 minus x2. Make sure that if you start with y1 here, you also have x1 down there. So the answers to be the same. Okay?
All right.
Yeah, so there's no problem, I think, on that. All right. Let's proceed now. So we have the given problem. So our problem, so our example is given to us. It's x cubed plus 3x squared minus 1 equal to 0. So we're only given x naught equal to -3. So this is what exactly I was talking about. Oh, for you to use this method, you need to have 2 approximations. So I'm going to choose another value. Okay, so choosing the extra value. So I'm going to choose the extra value. What other value am I supposed to choose?
x1.
What's the value of x1? Choosing x1 to be equal to what? And it should be close to -3. At least make it as close as possible. Because if it
-4.
Sorry, -4. That is very big distance in between one.
-2.8.
Okay, I think -2.8 can make sense. Because look, if you choose a value that are very far apart, you're going to have a lot of work to do, a lot of iterations for it to converge, isn't it? So yes, even -4 is okay. It's going to converge, but it's going to take a lot of iterations. Okay, so take note of that. It's going to take a lot of iterations. So you can either choose, you can even choose a value which is above -3, or the value is below -3. Okay, so you can choose -3.5 if you want, okay, or -2 point something if you like. There's no restriction. Okay, so for us to start this method, we have to make sure that we have 2 values of x, the starting value. So it means that okay, now since we have x naught, we're given x1 is given, so it means we're going to start from n equal to 2. Okay, so we're not starting from n equal to 1 or n equal to 0, because n equal to 0, for n equal to 0 of x not equal to -3, for n equal to 1 of x equal to 2.8. So we're going to start from n equal to 2, isn't it? Is that okay?
Yes.
Yes.
Okay, so start from n equal to 2.
Sorry. Come again on that one. I didn't get
I was
it.
saying that since we are given 2 values as x naught, okay, equal to -3 and x1 equal to 2.8, for us to start doing the iteration, we have to start from n equal to 2. If you look at the Newton's-Raphson method, we're only given x naught. So no wonder we're starting from n equal to 1, isn't it? We're only given x naught. No wonder we're starting from n equal to 1, as you can see here, right? We're just given one value, which is x naught, when n equal to 0. So when n equal to 0, you have the value of x is -3. N equal to 1, n equal to 2, just like that. Now for second method, since we are given 2 values of x, which is the starting values, so we have to start from where? We have to start from n equal to 2, because we are given n equal to 0, we have -3, n equal to 1, we have chosen this as -2.8. This one we just chose it, okay? We just chose it. So it means that I have to start from n equal to 2. Is that clear?
Yes, it's clear. Thank you.
Okay, so we start from n equal to 2. So for n equal to 2, let's see what we get, right? So for n equal 2, it means this method now, let's substitute 2 everywhere you see, okay? So it means that that method becomes what? x2. So we're going to find x2 equal to, this will be x1, okay? Minus f of x1, okay? And then multiply by, okay? This will be x1 also, minus x0, right? Because if you put 2, it'd be 2 minus 2, that is x0, divided by f of x1 minus f of x0. So you notice that we have x1 given to us, x0 is given to us, so we can just find what those values are, isn't it? Okay, so let's find f of x1 first. So f of x1, our x1 we chose negative 2.8, this is f of negative 2.8. Okay, let's hurry up, let's find what is f of negative 2.8. Okay, so this is negative 2.8. I hope you guys have already grabbed your calculators. Okay. So let's see, how much is that? Let's hurry up. We should take not more than 10 seconds just punching. Yeah?
44.
How much is this?
44.472.
Are you sure? It's positive or negative?
Negative. Positive.
Is that what everyone is getting? Are you sure?
Yes.
I don't think so. I'm getting negative 18.952.
Oh, what's happening?
Because this is negative, positive. So I don't think they can even go up to 44 something, right?
2.8.
So confirm that you're getting negative 18 point something. Oh, in fact, it's not even 18. Okay. Also made a mistake. I've skipped something here. It's not even 18. Okay. 15. Have you confirmed that? Negative 15.112. Have you confirmed? Okay. And then let's find f of x2. Oh, sorry, x0 also, because we have it in the equation. So this is f of negative 3. So this is a negative 3 to the power 3. Have you people confirmed? Oh, and I forgot. Yeah, did I even forget? No. Actually, this is not true also. Oh, yeah, this is 0 point something.
Yes, it's 0.568.
Yes, 0.568.
Not sure.
I'd left out a 3 or so when I was punching myself here. For that.
Oh, yeah.
So this is negative 1. We all know this, so it's negative 1, isn't it? Okay, now we have everything. We can now substitute, find x2. So our x2 will be equal to, what is our x1? Our x1, we chose negative 2.8. Okay, minus f of x1, which is the f of x1 is 0.568. So we just substitute here 0.568. And then what is our x1 is negative 2.8 minus our x0, which is negative 3. So this will be plus 3. Okay, divided by, I'm just substituting, right, in the formula. F of x1, which is this, is 0.568 minus f of x0 is plus 1, right? So this will become plus 1. Okay, so let's see how much we get there. How much are you getting? Okay, let's hurry up. So I'm getting negative 2.87 something. Confirm. 87244897959. Try to confirm that. Okay, so that is our x2. So you can now check if you wish. Okay, so you can check, but I don't think it's going to converge. You're going to arrive at that condition. You can check, find the error. This will be x2 minus x1 divided by x2. You can check this. Check this, okay? x2 minus x1 over x2. You can do it at your own time. See, but I don't think it is going to convert. I mean, it's going to be less than 10 for -4. I don't think so. Let's do some more iteration, okay? So let's find x3. So it means that now for n equal to what? N equal to 3. Second of x3. So our x3 now, if you put a 3 there, okay, everywhere this formula here to be, this become x2, f of x2, right? This become x2, f of x2, this becomes x2, this become x1, and all that. You can see that, isn't it? Okay. So this will be x2 minus f of x2 times x2 minus x1 this time around for n equal to 3, divided by, okay, f of x2 minus f of x1. So we already have f of x1, so we just need to find f of x2, right? Isn't it? F of x1 we will have it, and we found what is 0.568. So there is no need to worry that one, right? So let's find f of x2. So f of x2, this is x2, not xn. Okay, so f of x2 is equal to f of our x2. We chose x2, so our x2 is what? Oh, we actually found as negative 2.87. 244,897,959, okay, is equal to, so we can substitute those values in the function, which is a negative 2.87, whatever you people can finish the values there, you can put all the values that are required, and then 3 negative 2.87, okay, squared minus 1, right? So how much is that? Okay, so let us find out. How much are you people getting? Let's hurry up. We have less than 10 minutes left. Huh? So I'm getting 0.052 of them. 418. Sorry.
Oh, I'm getting the same 0.0592, please.
Okay, all right. So that is f of x2. Now we go back and substitute in the formula there. This is x3 equal to, so our x2 is that's a previous value just from calculating 2.8724. So you can finish all the values there. And then minus f of x2, we've just from calculating, just from finding this value as 0.52. Okay, now 41, can finish those values there. And then our x2 again is negative 2.8724. Finish all the values minus our x1. What was our x1? Our x1 was 2.8, right? We picked 2.8 as our x1. So 2.8, and then divided by f of x2, okay, which is f of x2 is this value here, 0.00. Oh, sorry, 0. This not 0, 0. Okay, this is 0.52, right? 524, whatever there, okay? Minus f of x1. What was f of x1? Which is 0.568. So let's see what you people are getting from there, okay? So negative 2.87, 244, 89, 79, 59 minus 0.052, 41, 87, 67, 92, okay? And then times negative 2.87, whatever. Okay, 2448,979,59 plus 2.8 over I've messed up. What are people getting there? I've messed up. What are you getting? I need your help. I've messed up punching all those values.
I got negative 2.87981.
Negative 2.8
79 81
81
48
48
15.
15. Okay. Anyone else will take this value? Okay. But yeah, it's not very much far from this x2. It's like they're almost the same, not so?
Yeah.
Almost the same. So we can believe that, isn't it? So you can also check the condition. I'm not going to check that condition. Please make sure that every time you do the iteration, you check the condition, this one. So this will be x3. So check this. Okay, so x3 minus x2 now divided by x3. Let's see what you get. Is it less than 10 to the power negative 4? If it's not, please continue. Find more iterations as well. So you can also continue. Go ahead and find x4. So x4 we got what? x3 minus f of x3, right? And then time we see x3 minus x2, okay? Divided by f of x3 minus f of x2. Okay, so again, you can check that condition. So you can just substitute. You have all these values. X3, you have it. F of x3 is when you substitute this guy, right? In the function, you get f of x3. Okay, you have order of x2. X2 already found the value, which is x2. What was our x2? Was this one here? Come and substitute it. You find x4. So that's how second method works. So there's nothing complicated about it. Is it clear? Is this clear?
Yes, it is.
Okay, so second method, that's how it works. You don't need a derivative to apply second method. So try other questions as well. So you can also try the rest of the questions. It's the same procedure. But be careful when you're dealing with these questions that contain trig functions, okay? This one that contains trig, this one that contains trig. Make sure that you get as radian mode, okay? Because here we're dealing with trig functions. So I already advise that, okay, whenever you say trig function, you're dealing with that function, like in this course. You have to make sure that you convert your head in radian mode, okay? That's very, very important. If you forget, then you are gone. You end up getting wrong values. Okay, so any question, please? Can you manage to do question 2, 3, and 4? Try them, practice. Okay, so for this one, I'm going to explain here, okay, on this question. So I have 2 minutes left. From this question number, I know question number 4, people are going to have difficulties maybe finding the derivative of this guy when you're using it. No wonder that's no wonder second method is very important, because you're going to avoid this derivative thing. Don't be there when using second method, isn't it? So when you're using Newton's Raphson method, how are you going to differentiate that one here? So I have 2 sine x minus 2 to the power x over 4. It's to the power, right? How do you differentiate this one here? So remember that we're using Newton's Raphson method. Please mute your mics. Mute your mic, please. Okay. So you have to differentiate this guy, right? So you know that the derivative of this guy is f prime of x will be equal to 2 cosine of x, okay? Minus here, you have to differentiate 2 to the power x over 1 over 4, right? So we're going to first differentiate the power, isn't it? So what's the derivative of x over 4? That is 1 over 4, isn't it? So that's a row, okay? And then multiply by the same function, which is 2 to the power x over 4, and then times the natural log of the base of that function, which is 2. So the base in this case is 2. So the general rule is that if you have a constant a to the power f of x, the power function of x, a constant a, the power function of x. So the derivative of this guy just becomes, so respect to x, it just becomes the derivative of the power, which is f prime of x, times the same function, a to the power f of x, times natural log of the base itself. So that's a rule. Is that correct? Is that okay? So if you find difficulties differentiating the fourth question, this are going to do it. Is that okay?
Yes.
Please try to revise the other questions. Go through them, practice. If you come across any challenge, let me know, okay? So if the people challenges other questions, we can also pick one question next time. We still have a lot of days between now and Friday. Don't worry. Okay, so for tonight, I think I'll end here. I have other things to do. There's a lot of work I need to look at.